Hello, this is Eduardo Suarez. Today we're going to look at a vision system application using iRVision 2D with a robot-mounted camera. If you have never worked with iRVision, it can look a little bit intimidating at first glance, but I'm going to show you that the configuration is relatively simple. The objective of this application is that we're going to have a torque gun mounted in the aerodynamic tooling, and also we're going to have a camera mounted beside it. We're going to find the location of 2 bolts on a frame, and we're going to torque the bolts positioning the aerodynamic tooling with the offset given by the vision system. We're going to start by getting the iRVision manual. We're going to go to fanocamerica.com. We're going to log into my portal. We're going to go to events, and we're going to type iRVision. And you're going to find that the manual is the one that says iRVision Operator Manual Reference, and the edition is edition 6. You're going to find that the manual has a very detailed documentation on all the possible options that you have when using iRVision. You're going to see in the manual that basically there are 2 possible configurations for the camera. It can be a fixed camera mounted on a stand, or it can be a camera mounted on the robot, and in this case it's called robot mounted camera. We're going to start a work cell that I have already created. We're going to go to robot controller. We're going to go to properties, and you're going to see here that I have already installed the option package, iRVision 2D package, that is R685, and also I'm using the robot M710 IC50. When you install iRVision, you're going to see there is a new subset that is shown in the cell browser, and is vision here. So the first thing we need to do, we need to right click, and we need to enable the vision simulation. At this point, the robot controller is going to reboot. Next thing we're going to do, we're going to go to the aerodynamic tooling, and on the aerodynamic tooling, what we're going to do, we're going to add the camera. So we're going to select the aerodynamic tooling. We're going to select add vision sensor unit. We're going to select add to the camera and add from the library. In this case, we're going to select camera, and the camera I'm going to be using is the black and white, and we press OK. So the camera is going to be added to the aerodynamic tooling. What we need to do now, we need to reposition the camera. So I'm going to select the camera here. I'm going to go to properties, and I already know the position of the camera, so I'm going to type it manually. And I have already the camera mounted in the position that coincides with the drawing for the CAD. You're going to see a few more things on this window, we can go to settings. Here you're going to find the image size and you're going to find the focus length. You can change the focus length with the camera you're using. In this case, I'm using a 12 millimeters, but you can change to all these options that you see here. And in this case, the offset was set automatically, and this is the offset of the camera in a reference to the sensor. We can go to view, and on view you're going to see the field of view, and we can make it visible or we can make it invisible, and also we can change the height, but we're not going to make any changes to that. Once we have added the camera, the next thing we need to do, we need to go back to Vision, we need to right click, we need to go to Properties, and we need to connect the camera to the port number 1. So we're going to select port 1, and we're going to connect the in the controller. We're going to press Apply, and we're going to press OK. If we go to the menu, if we go to Robot, we can select Internet Explorer, and in here you're going to find iRVision. On the page for the revision, you're going to find the tutorials. We can select the tutorials, and you're going to see that the tutorials is divided into parts. It's going to be one for the 2D position offset with a fixed camera, and the other one is for the robot mounted camera. So in our case, we're going to select the robot mounted camera. You're going to see that the tutorial is going to guide you through all the steps, all the workflow that you need to follow for configuring iRVision. And in our case, we're going to follow the same procedure that you're going to see here. We're going to create a program, we're going to set up the camera, and we're going to set up the vision process, and finally we're going to test it. Two important steps that they are not mentioning here is that before we start doing this, we need to set up the environment tooling, and we need to set up the user frame. So we need to set up the user tool, and we need to set up the user frame. That's very important, and there are the two steps that we need to follow before coming here. So we're going to close this one for a moment, and we're going to go back to the cell. On the work cell, we're going to select the user tool 1. We're going to go to Properties, and in this case I already selected the user tool, and I position the center point on the tip of the torque gun. In my case, I'm missing the socket on the CAD drawing, but there should be a socket in here that's going to fit in the bolt. In any case, I put the user tool on the tip of the torque gun. Now we're going to open the stitch pendant, we're going to split the screens in two. We're going to select the user frame, and we're going to create a new user frame. I'm going to go to details. We're going to give it a name. This is going to be the user frame for the bold one. And now, if we go to method, these are the three methods that we can use for the setting up the user frame. When you're using Vision System, you need to set up the 4 points method. So that's the one we're going to select. We're going to minimize this one for a moment. And the next thing that we need to do now, we need to bring the calibration grid. So we're going to have a calibration grid for each one of the bolts. For purpose, you need to come to fixtures, and from fixtures you're going to add a fixture. You're going to go to the CAD library, and from the CAD library you're going to select the vision.parent calibration, and from here you have all the calibration grids that you can select. We're going to select this one in here, and I have that already installed. These are my two calibration grids for bolt 1 and bolt 2, and we're going to make this calibration grid visible. So in this case, I have my calibration grid that on the surface of the frame, and is almost in position in the center with bolt number 1. I want to show you this calibration grid in more details, how it looks like. So this is the calibration grid provided by FANOC. It has several dots, and you're going to see that the dots on the corners, they have a small white dot, and also there are dots in the center, they are bigger than the other ones. In particular, there are the 3 dots shown in here. This one represents the X direction, and the other 2 dots represent the Y direction. And also there is a white dot on the center, that this one represents the system origin. So one on the corner is going to be the origin. You're going to have the X direction, you're going to have the Y direction, and you're going to have the system origin. That's why we need to use the 4-point method when we're using iRVision. So we're going to go back to the work cell, and what I'm going to do, I'm going to make the frame and the bolts invisible so we can see properly the calibration grid. So I'm going to click on the conveyor frame that I have in here. We're going to go to parts, and we're going to make the parts invisible. We're going to go back to the teach pendant, and in this case you're going to see something else that I have already created a program. I call it a torque bolt 1, we can select the program, and you're going to see here that I have a few steps already created. I have a user frame, I have the user tool payload override, I have the home position, that's going to be the position register number 1, and then we're going to change the user frame number 1, that's the user frame we're going to teach right now. I'm going to keep the same user tool, and then I'm going to have different positions. I'm going to have a position 1, that's the position that the robot is right now. That's going to be in front of the calibration grid, and we need to set this position when we want to take a picture. But this is the same position I'm going to use for teaching the user frame. And then we're going to have when the part is fine and we have the offset, we're going to go to the approach position, the torque position, we're going to wait, and we're going to go back to the approach position, and we're going to go back again to the home position. So for now, we're going to keep the robot in this position, and we're going to go back to the setup frames and the user frame that we have in here, and we need to start going through the steps of the setting the frame. So first thing we're going to do, we're going to select the origin, and in my case, I'm going to zoom in here. The origin is going to be this position here. One more thing that you can use is adding a tip on the torque gun, and in my case I have a pointer, so I'm going to make the pointer visible, and this pointer is going to be used for making the setting more precise. So you can see that there is a pointer at the end, and this pointer will be should be placed on the socket. So here, because I am a robot guy, I can just go to that point. So we're gonna go to the origin as close as we can, and here I am in the origin position, so we're gonna press Shift and record, and we have already this point dot. Now we need to go on the X direction, so we're gonna go to the other point on the calibration grid. We can select this point here, and we're gonna press Shift, record. Now we need to select the Y direction, we're gonna select this point on the calibration grid, and we're gonna press Shift, record. And you need to be as precise as you can. Next and finally is going to be the system origin, and the system origin is the point, the Y point on the center. So we're going to select that point, and we're going to press Shift, record. And now we have all the points taught for the user frame. We can do a preview, and we have the user frame in here, and also we can select the tool frame, and we have the tool frame already here. The next thing that we can do, once we have the user frame taught, we can go to select the program, enter, and we can record this position. So what we want to do, we want to take the robot back, and we're going to move the robot only on the Z direction, taking away from the calibration grid, and we can teach this positioning here. That's going to be the position where we're going to take a picture. In my case, I have already the position taught, so I don't need to return that position again. But what we're going to do, we want to move to this position. So what I'm going to do, I'm going to run everything from the start again. I'm already in that position here. So that position is where the camera is going to be looking at the calibration grid. What I'm going to do now, we're going to go back to the website. We're going to go to iRVision, and this time we're going to select iRVision setup. And the iRVision setup is going to be two processes. We're going to set up first the camera, and then we're going to set up the vision process. So because we don't have anything yet, the first thing is going to show up. It's going to say create a new vision data. So we're going to select the create button, and we're going to have this pop-up window here. We're going to give it a name. We're going to select vision bold 1, and the process we want to do is going to be one for the bold 1 and another one for the bold 2. And the process is going to be exactly the same for bold 1 and bold 2, so I'm going to show you only one. We can give it a comment. We can call it the vision for bold 1. The type is going to be a 2D camera, and we're going to press OK. So now we have the camera data here, and we're going to select Edit. And this screen is going to guide you through all the steps that you need to take. So right now we are in step number 1, that is the camera setup. So in here we're going to select the camera, and one important thing that you're going to see a note over here. If you click in this note, we want to use the advanced method. You can change the mode and use the basic method, but the basic method is not going to show you all the options that you need. So you want to make sure that you are on the advanced mode. So we're going to select the camera. In this case, it's the camera we're using, the SC130EF. And you can see right now that it took automatically a picture, and we're looking through the camera, seeing the calibration grid. So now the next question is going to be, if this is a robot mounted camera. Select yes. And every time that you see a bullet here, you can click on the bullet and you're gonna have some help about that selection in there. So this is the method that we are using right now. It's gonna be a robot mounted camera. This robot holding the camera is this robot on group 1. Axis mounted camera. Axis is going to be on the aerodynamic tooling. Let's keep all these settings in here. This would be for the real application when you need to do adjustments to the brightness, the exposure times, etc. Also, you need to do the calibration of the focus. That we don't need to do that in here. And that would be this option in here, focus and aperture. So you can select this option in here, and you're going to go through all the process that setting your actual camera. And then on calibration, what calibration we're going to use? We're going to use the grid pattern calibration. So at this point, we can save and we can go to the next step. You can see we have a green check mark that this step has been complete. We're going to go to the next step, is calibration setup. On the calibration setup, you can make an adjustment in here for the zoom. You can zoom in or you can zoom out. We want to select the application frame. In our case, the application frame is the user frame number 1, is the one we already taught. The grid spacing, that's going to be the spacing for the dots that we have in the calibration grid. In our case, we're using a 15 millimeters spacing. When you get your calibration grid, it's going to be written down on one of the borders, the spacing of the calibration. But if you don't know, what you can do, you can measure that. So in our case, we can select the measurement tool. We can select from, we can select one point in here, and we can select 2, and we can go to the next point in here, and you're going to see that the distance is 15 millimeters. Robot head calibration, no, the calibration grid is fixed, and the setting the calibration grid position method is going to be the user frame. And now we have a green check mark on the calibration setup. We're going to go to the calibration grid location, and in here we're going to select the user frame number 1, and we're going to press set. And in this case, it's showing up the position of the calibration grid relative to the application frame, and the position is 0 because we haven't moved the calibration grid, and this is the one we have used for the teaching the user frame. So there is it's not going to be any offset in here. The position is going to be 0. We're going to select calibration. The number of planes we're going to use is 1. You can select 1 plane or 2 planes. If you want to select a more precise calibration, you can select the projection. You can use orthogonal or perspective. In our case, we're going to use the perspective projection. The camera distance, you can have the option to do that automatically, or we can override the focal distance. In our case, we are going to override this distance, and we're going to use the 12 millimeters that we already know is the focal distance for our camera. And now we're going to find the plane. So we click on find the plane, and you're going to see here that there is a window, and there are control points on every corner and on the center line. So we're going to drag this one, and we're going to include all the points that we have for the calibration grid. And in this process, you want to select as many points as you can from your focal view. In our case, we are selecting all these points that you can see here. So now we have this one in here. You don't want to include any more points that they don't belong to the calibration grid, because otherwise the calibration grid is not going to be good. So we're going to press OK, and this is telling us the calculated standoff distance is 405.9 millimeters. Okay. So this standoff distance is the distance that we have from the calibration grid to the actual camera. So again, we can measure the distance, and you need to verify that the distance calculated for the calibration is the same as the distance, the physical distance that you have on your system. So we're going to select the measurement tool again, and we're going to go from the calibration grid to the camera, and you're going to see that the distance is approximately the same. It's in the order of 405.9 millimeters. So that's the distance I'm getting here. So we're almost finished with this calibration. We're going to go to the calibration points, and you can see here that these are all the points that we find by the camera, starting from the center and going around. And you're going to see here a table with each one of the points. If you see something in red, that is bad point, and you can delete that point if you want. So the only thing you need to do is just find out the point number, identify the point number in here, and you just select that point, and you can delete it. And the calibration result is going to give you all the details about the calibration, the focal distance, the standoff distance, the lens distortion, and the position of the camera relative to the calibration grid, the position of the calibration grid relative to the application user frame, and the position of the robot holding the camera. So what we're going to do, we're going to save this. We are done with this calibration, and we can end the editing. So what we have done with the calibration is we found the relationship between the pixels in the camera and the position in millimeters, and we also found the position of the calibration grid in reference to the user frame. The next steps that we need to do, we need to create a vision process. And for creating a vision process, we select again create, and in this case we're going to give it a name. We're going to call it vision process Pod 1, and here are all the vision process possible. you're going to find a very extensive explanation of each one of these vision process on the iRVision reference manual. The one that we're interested right now is the 2D vision single view vision process. So we're going to select this one and we're going to press OK. Now we're going to select Edit and we're going to go through the procedure of setting up the process. We're going to find here on the top there is a tree, and this is divided in the vision process pattern, and whatever you see behind this one underneath is going to be the child. So this pattern process has three childs: is the snap tool, the GPM, and the offset data. We're going to select first the pattern tool, and we're going to do the setup. We're going to select the camera. The camera is the calibration that we did already. That's vision for both 1. And you can see here that automatically it gives a snapshot. And now the offset mode is going to be, we're going to select the fixed frame offset. The user frame that we're going to use is the user frame for both 1. And we're going to skip all this setup, but basically this is the how it's going to find the part. One thing that we need to do, because the vision process is going to find the bold location, we don't need the calibration grid anymore. So we're going to make the calibration grid invisible, and we're going to bring back the with the frames. One thing that you need to notice is that I've never moved the calibration grid from the moment that we taught the user frame, and through the process of the calibration I haven't moved the calibration grid, and also I haven't moved the camera. So we're going to select the fixture, and we're going to select back. We're going to put them back. The bolts, we're going to select the frame, and we're going to put the washers. Select the calibration grid, and we're going to make the calibration grid invisible. So now we have the bolt number 1. Select the snap tool, and what we're going to do, we're going to take a snap, and you're going to see now the bolt as is seen through the camera, and it's finding we can zoom in, and you're going to see that it's the washer and the head of the bolt. Here on the snap tool, we're going to select set, and again we're going to find the location for the piece that we need to find. We're going to select this one in here. The resolution, we don't want to make any changes to that. Exposure mode is going to be fixed, and we're going to select now the GPM, and the GPM stands for Geometric Pattern Matching Location Tool. On the GPM, we want to select teach, and this is going to teach now the part that we want to find. So we want to teach this part in here, and we're going to select OK. And the part was fine. So in this case, it's identifying only the washer, but in your real situation, it's going to identify the washer and the head of the bolt. We are not really interested in the orientation of the head of the bolt. So what we can do, we can mask this part if this part is identified by the vision system. I'm going to show you in a moment how to do that. We can set the origin, and we can set the origin and move this one around. So my origin is going to be over there. And here it's going to tell you the training stability, so the location is going to be the angle and the scale. Here we have the training mask, and if you find that your vision system is detecting the head of the bull, you can enable that, and you can edit. And in this case, what you can do, you can mask that. So the way that you're going to mask it is going to select a pen. You're going to select the thickness for the pen, and you can just paint it that, and you can mask whatever you don't want to find or whatever you don't want to be detected by the vision system. So what you can do, you can select this one, and this is going to be masked out. In our case, this is not detected, so we don't need to do that. The learning method is going to be if you have several parts, if you have several images already selected, and you can go through each one of the images and do a learning process. We don't need to do that in our case. The model ID, we're using only one part, so our model ID is going to be only one. And the score threshold, you can select in here what is going to be your threshold for selecting a good part or a bad part. In our case, it's going to be a 70%. That is going to be a combination of all the three different tools or child tools that we have in our vision process. This is going to be the constant threshold. It's going to be the constants between the white and black. The area overlap, when you have two parts identified, how it's going to detect if you have two separate parts or it's only one part. It's going to be by the area overlap. Elasticity is going to be giving you some ratio between the model part and how part that you find from the model. DOF stands for degree of freedom, and in your case you want to have some degree of freedom because you want to give some flexibility to the part that you're finding. Your part normally is not going to be exactly the same as the part that you have used as a model. So in our case, we can select the orientation. We're going to enable the orientation to be from minus 180 to plus 180 degrees. The orientation is not relative in our case. It's not relevant in our case because we're looking at the washer. And you can also change the scale. You can go from 90% to 110% of your model, and the aspect ratio you can change that too. Now we're going to select the offset data calculation, and the reference data to be used is going to be static. The part Z height, we need to set this one up, and in our case we're going to select 5 millimeters, and this Z height is going to be the how far apart is going to be the part from the calibration grid. So in our case, we set up the calibration grid flat to the frame. You can see here that the pole is sticking out from the frame because it hasn't been already torqued. So we're going to measure the distance again. We're going to select from, and we're going to select the frame, and we're going to go to the part, and the distance is like 5 millimeters. So in our case, we're going to select 5 millimeters. We're going to select set for the reference position status, and this is the part that we found, and it's going to give us the reference on the X, the reference on the Y, and the orientation relative to the calibration grid that we already have. And yes, we have finished already our vision process, so we can save it and we can exit the editing. We're going to go back to the program, and we're going to finish off teaching these points. So we're going to step forward, and we're going to teach the approach position. It's going to be shift touch up, and we're going to teach the torque position. It's going to be shift touch up, and just you have to make sure that you are in the user frame number 1. So you're going to notice that the orientation of the bolt is not relevant in this case, because the torque gun is going to have some compliance, and the socket is going to be able to fit in the bolt head as of the orientation of the bolt head. So now we're going to run this program again. We're going to go step by step. We're going to go to home. We're going to go to the position for the vision. We're going to go to the approach, torque position. We're going to wait. We're going to go back, and we're going to go to home. So this process worked. One more thing that we need to do now, we're going to go to the point after we are in the vision position, and we're going to add a few more lines. Here we're going to add instruction. We're going to select instructions, and we're going to go to vision, and we're going to select run find. What we're going to find is going to be the vision process for bolt 1. Then on the next line, we're going to select another instruction. We're going to select vision again, and this time we're going to get the offset. Again, the offset is going to be for the vision process for the bolt 1, and we're going to save the offset position on a vision register, and in this case we're going to select the vision register number 1. And part of the instruction is going to be a jump label. We're going to select label number 9, and this is going to be in the case that the vision process failed, that couldn't find the part, and in that case we couldn't find any offset, so it's going to jump to label number 99, and in this case label 99 is at the end, and over here you should have more instructions that, for example, just give an alarm. So one more thing that we need to do now, that we have the offset, we're going to add the offset to the approach position and the torque position. So we're going to go to the end of the line, we're going to select choice, and we're going to select the offset, vision offset with the vision register number 1. We're going to add it in here. We're going to add it at the end of the position for the torque. And also we're going to add it in the position for the position. Okay, so now we're ready to run the program again. We're going to start from the beginning. And we're going to change this data. We want to show the vision registers. And in particular, we're looking for vision register number 1. So we're going to select detail. We're going to go back to the program and we're going to run the program. We go to home. We go to the position for the vision. We're going to run the vision. We're going to run the offset. You're going to see here that the offset is 0 because we haven't moved the part. The part is the model part that we taught before. So the offset is going to be 0. And now this offset is going to be applied to the approach position, the torque position, and the retract position again. So we're going to run these motions. We're in the approach position, we go to the torque position, we're going to wait, and in this case, in your real program, you should add a few more lines, like a digital output that is going to control the torque gun, and you should have something that is going to look at the alarms in case that the torque failed. And we can go back to the retract position and go back to home. So now, one thing that we can do, we can minimize this one. Noticing here that still we have the pointer. We don't need a pointer anymore. We can make that invisible. We're going to go back to the process. We're going to edit this one. And one thing that I want to make sure, the snap window, we're going to open it up. So we're going to make this snap window a little bigger. So we're going to move the part and we're going to be able to find the part again. So we're going to do something like that. We're going to save it and we're going to exit. Now we're going to go back to here and we're going to go to the conveyor. We're going to select properties. We're going to select the bolt 1 and we're going to move the bolt. And we're going to do the same with the washer. Remove it by 5 and 6 millimeters. Now we're going to go back to the program and we're going to run the program again. We're going to take a picture we're going to get the offset. And you can see that the offset is going to be 6 and 5 millimeters. And we're going to go to the approach position, and we're going to go to the position. And you can see that the torque position is with a new offset. We're going to wait, and we're going to go to the retract position and go home again. Now I'm going to show you how the application looks with the two vision processes. We're going to go to iRVision, and you're going to see here that I have a calibration for the Volt 2 and vision process for Volt 2, exactly the same as we did for Volt 1. We're going to open the teach pendant, and you're going to see, if I go to menu, setup, frames, user frames, now I have a user frame number 2 that I set it up for the Volt 2, and now we can select the programs, and I have a program for the torque that is going to look exactly the same as the one I did for Volt 1. The only difference is going to be that now I'm selecting the user frame number 2, and I taught the positions for the vision, the approach position, the torque position, and the retract position according to the user frame number 2. And when I call the vision run file, I'm using the process for vision process for Volt 2. And when I get the offset, I'm getting the offset on vision register number 2. And then I'm gonna do the offset for the position using the vision register number 2. So everything is just a copy from what we did for Volt 1. We're going to select again. We're going to select the main program, and we're having the main program, then the torque for Volt 1, and then encoding the torque for Volt 2. I set a new arbitrary position for Volt 1 and Volt 2. So now you're going to see that the vision register for Volt 2 is going to show up a new offset. We're going to run the program. We're going to run directly without using steps. So we're going to go to Volt 1, take the picture, torque, retract, go home, Volt 2, torque, retract, and go home. In summary, we set up a vision process using iRVision 2D with a robot mounted camera. We follow the workflow that is shown in the tutorial. You can see that the process is very simple. We only have to add 2 more lines in the program, one that is calling the vision run, and the other one that is getting the offset. We moved arbitrarily the part by the offset given by the vision system and get to the target position.